Part B. Now we're asked to find the area of the cross section of the gutter. So this would be this whole area over here. Now to find this, we can divide our cross section area here into two different regions. We can divide this into, if we draw a line A to B, and this is going to have a length of W, we can divide it into this rectangle over here. And I'm just going to call this area A1. And then we have this curved area over here, which I'll call A2. And then we can just find the area of each of these individually and then add them. So A1, well, this region is a rectangle. The base is W, the height is 10. Area of rectangle is base times height, so W times 10, which is 10W. And then A2, well, to find A2, we can find the area of the whole sector, AOB, and then subtract from the area of this triangle. So I'm just going to say A2 is equal to area of the sector minus the area of the triangle. So let's find each of these individually. So first we have to find W. So let me just draw out this triangle OAB. So triangle OAB. This side is 12. OA would also be 12 since this is also a radius. And then this angle is theta, which in part A we showed is equal to 2.08. But I'm going to leave this as fractions. Theta is 25 over 12, which is the same as 2.08. And I'm just going to use a fraction to get a more exact answer and avoid rounding errors. And then this last side of the triangle is W. Now to find W, we can use the cosine rule, which says c squared equals a squared plus b squared minus 2ab cosine of c, where lowercase a and lowercase b would be the two sides that we know, and capital C is the angle between them. So lowercase a would be this side, this would be lowercase b, two sides that we know, and c would be w. So I'm just going to rewrite this as w squared equals the side ob squared plus oa squared, I'm not sure if I'm going to have space, minus 2, let me buy myself a little bit of space. So w squared equals ob squared plus oa squared minus 2 times ob times oa times cosine of the angle between them, which is theta. Let's sub in our values. We have 12 squared plus 12 squared minus 2 times 12 times 12 times cosine of theta, and we'll use 25 over 12 for theta. And you can use 2.08 as well. So anyway, let's do this on the calculator. So go to our calculator. 12 squared plus 12 squared minus 2 times 12 times 12 times cosine of 25 over 12. And we have to make sure that we're in radians here, not degrees. And we get 429.23. But this is W squared. This is not W, 429.23. So W is going to be the square root of this, which is going to be square root of my answer, 20.71792. So I'm just going to say 20.718. 20.718. Therefore, A1, which is 10W, is going to be 10 times 20.718, which is just 207.18. All right, so we got A1. What about A2? Well, we have to find the area of the whole sector, minus the area of the triangle. Well, let's go to a new page here. So we have this sector, which I'm having trouble drawing. So looks like this. OAB, the radius is 12, and the angle is theta, which is 2.08 radians, or more precisely, more exactly, 25/12. Now the area of a sector is, as given in the formula booklet, 1/2 r squared theta, where r is the radius of the sector and theta is the angle of the sector in radians. So here we'll have 1/2 times 12 squared times 25/12. And then let's see what this is equal to. So 1/2 times 12 squared times theta, which is 25/12. We get exactly 150. So that's the area of the sector. And now what about the area of the triangle? Well, the triangle OAB, so this area over here, we can use the formula area equals 1/2 AB sine C, where A and B, lowercase a and lowercase b, with the angles, the two sides that we know, and C would be the angle between them. So the sides 12 and 12, and then the angle between them is theta. So this area over here is going to be 1/2 times 12 times 12 times the sine of theta, which is 25/12. So we have 1/2 times 12 times 12 times sine of theta, which is 25/12. And again, make sure we're in radians. We get 62.748. 62.748. Therefore, A2 is the area of the sector minus the area of the triangle. 150 minus 62.748. Let's see if we have space here. So 150 minus 62.748. Let's go to our calculator. 150 minus our answer, 87.252. 87.252. Okay, so we have A1, we have A2, so the whole cross-sectional area is going to be the sum of both of them. A1 plus A2. So 207.18 plus 87.252. So our answer plus 207.18, and this is rounded, we get 294.43. 294.43. And now just rounding to three significant figures, our area is going to be 294 centimeters squared. That's the answer to part B.